In this series, I'm going to talk about modeling using Comsol Multiphysics. Um, but we will start the first session as an introduction. So we will explain a bit about the interface, how to use the software in general, and then in the other sessions, maybe we can model some simple and go to some complicated problems maybe at the end. So at the beginning, we will talk about how to use the interface or how or what are the modeling steps using Comsol Multiphysics. They are pretty much the same modeling steps in almost every software, let's say, or most softwares. So Comsol Multiphysics, first of all, a word about the software itself was found to model at the beginning solid mechanics, and then through the years, several modules were added: fluid mechanics, fluid flow in porous media, heat transfer, mathematics module, and many other things. The software is based on finite element method because finite element method is the best in solid mechanics. So this is why finite element is the background or the used in this software. As we know, different softwares use different numerical methods, but finite element is one of the robust for or the most robust for solid mechanics. So if we open Comsol from its icon or from start, we will get this window. And we have here model wizard and plant model. So in model wizard, we can choose, let's say, the physics that we want to use it in our model and define it from the beginning and define what kind of study I want to do, if it is stationary or a transient study. And in blank model, I will get an empty model and I can add the steps that I added at the beginning in model wizard from the blank model, from the blank, let's say, interface. So if we open at the beginning a model wizard, so we'll see here that we have different, let's say, models we can use in our study. So we have 0D, 2D, and 3D. So 0D can be used to solve, let's say, equations, whether they are algebraic equations, PDEs, ODEs, whatever. You can also use them, plug the initial conditions, and model them. And then 1D, as you know, in one direction, then 2D in two direction, and 3D. Asymmetric when our model in 1D or 2D is asymmetric and the model is, let's say, big enough so to save some time and effort, so we can use asymmetric modules or model. So let's at the beginning click 2D. So we see here in uh, this window to the left hand side the modules that we have in Comsol. So as I said, we have, let's say here, recently used is not considered. Let's say close it. And we start from here. AC/DC is this electrical engineering, acoustics engineering, chemical species, chemistry and chemical engineering things with electrochemistry, and then fluid flow, CFD, heat transfer, optics, plasma, radio frequency, semiconductor, structural mechanics. That was the base of the software. And then mathematics. This is interesting. I mean, this is my favorite module, since you can play with mathematics. You can plug your equation if you understand your model well, and you can couple different equations together and solve your model. So at the beginning, let's start with fluid flow, and when we open this fluid flow, we see different sub sections. single flow, multi-phase, porous media, and so on. And after or under every one, you see also different options from creeping flow, laminar flow, turbulent. Turbulent, there are different turbulent models also. So we see here, if we click, and other models. So let's start with laminar and click. So when we just click in the left hand side, we on laminar flow, we see here where we can use laminar. So it gives some, every time you click on one of the modules here, sub modules I mean, you can see here a brief introduction where to use this model. So if we click add, so we get this physics added here, and then we can remove it, add other physics, or we can add 2 or 3 physics, 4 physics, as many as we want. And then we click study. So here we have, in this case, we have stationary time dependent. There are also other studies in other modules. We will see them later maybe. So let's click also time dependent and click done. So we will see here the main window of or main interface of Comsol Multiphysics. So we see here model builder, settings, and graphics. And here at the bottom, we see here messages, progress when we do modeling, and we see the log, for example, what during modeling, what the software is doing, and what time step we reached, and if there are any errors or something like that, everything is reported here. Also, when we also draw or click to find some results or to plot some or show some tables from the results also can be shown here in this place. The domain can be drawn here, or we can import it and we can see it here. So if we go to the left hand side to the model builder, so we start with modeling steps. So this our model, we did not name it. I mean, here we can also change the name, and so the model here is not named. So when we save it, we will see the name here. And from global definitions, we can see, first of all, parameters. I will show here only the main modeling steps. There are some other steps or other options during modeling or when you are an expert, so you can refine your model. You can also play with your model. You can estimate some variables or parameters. You can define all that from here, from the model builder. So parameters, let's talk about parameters. Parameters is the first step. I consider it very important because you can put your parameters here, and you put the expression, the value expression with, let's say, the unit. And you can put here brief explanation about what is your parameter. For example, if you put, let's say, P, and the value of P, let's say 1E5, and then let's say Pascal, and you can put here pressure, for example. So I consider this parameter section is very important, especially when you use the same parameter in different physics in more than one time. So sometimes you make mistakes by defining or typing different values in different places. You will, I mean, checking the right values for everything when your model is complex is very tedious. And therefore, I prefer to add your parameters from here and use this, for example, the value of P. So you just put P, and the software will take the P value with its unit and what is this P. And then we go to definition. I will not talk now about definitions, maybe later in the model, so we can see, because we don't have time. I don't want the video time to be um, very long. Then the next step is geometry. So also we click here geometry. Uh, we see here we have different shapes. We can use them. So if we click here, right click on geometry, we can see the same things. So we can see everything here and here also. So we can draw whatever we want here in the graphics window. And then materials. What are the materials of our domain? If we have several materials, we can use already built materials, or we can define our materials. For example, or there is a library here in Comsol. For example, if we right click and see the add material. So we see here some built-in and some other also materials in different modules. So for example, built-in, you will see the main materials that we see in our real life. Here, let's say here, water, cast iron, structural steel, whatever other things. So we can just click and just add to component. Let's close it now. And then we come to the physics. We have chosen, so we have here one physics, laminar flow. So we can add other physics also from here, from physics. Also, we can click and add physics. So we can choose another physics, let's say heat transfer. We go to heat transfer in fluids and then add to component. And then close this tab. So now we have two physics. So we can also define boundary conditions. So we have physics. So we can see here in the settings the equation that this module is using. This thing I like it very much in Comsol Multiphysics. So you can see the equation of every module you are using or every physics you are using. This is not available in black box softwares. So this is one of the most interesting things that I like about Comsol. And also initial conditions, boundary conditions, you can add here whatever you want, boundary conditions, other domains, physics. We will see that in the exercises. The same apply for heat transfer here in this case. And then comes multiphysics appeared here after we added heat transfer. So if we right click on this, we can see two options that we can couple the laminar flow and the heat transfer using these options. So for example, if we click on non-isothermal flow, so we see here that these are coupled together and we see here the equation also. So the nice thing that every module or every physics you can see here initial conditions for fluid, for example, you see here the equation also, whatever. I mean, the equations are available for everything here you define. Then mesh, the next step after we define the parameters, then the geometry, materials, the physics, then we come to mesh. We mesh our module or our domain. We have also different options here. The options are all of them are let's say not activated because we did not start any meshing process and we don't have a domain here. Then we come to the study time dependent. We choose here in our study, so we can define the length of our study, the length time of our simulation, and with the time steps, we can also plot results while solving. For example, for every variable or any variable in any point or any edge inlet outlet of the domain. So we see here that we have two physics, laminar flow, heat transfer, and coupled together. And then when we solve our study, whether it is time dependent or stationary, we get our results listed here. Of course, we don't get all the results. We will get the results. I mean, automatically Comsol is plotting the main variables, but you can add more plots. You can plot variables in different points at different edges. That depends on your problem. and the complexity of your problem. By this, I end this session, and thank you very much.